Okay, we studied the evolution of networks. What was the primary motivation behind studying of evolution of networks? That it has been observed that most of the real life network is not random, not random, they were mostly power law. And we know the way random networks are formed. Okay. What is the simple way in which random networks are formed? That we have first the nodes, and between each node we join with a probability p. Okay. This is also very unrealistic. What we thought, in most of the real networks actually grow continuously. Although it grows continuously, the degree distribution stabilizes. To something like power law. So the model, the basic model in which we want to explain is, there is a network, already existing network, and a new node joins this network. Okay. And we have studied the price model, okay, where we thought that its price was, it is a citation network, okay, and so every node joins with some in degree, some out degree, okay, which becomes in degree to some node. Okay. Now we talk about the Barabasi-Albert model. Okay. Barabasi and Reka-Albert suggested this model, which is basically the generalization of, or which is a simplification of price model, but before Barabasi-Albert gave this model, nobody knew about price model. Okay. So, price model although was in the 60s, but it was a forgotten model. So what is Barabasi model? Barabasi model, instead of thinking, makes life simple, does not think of any in degree out degree, thinks only in terms of undirected graph. Okay. So, undirected graph, what you have? You have an undirected graph, and a node joins the graph with, say, m links. Okay. A node joins the graph with m links. When a node joins the graph with m links, what is the attachment rule? Attachment rule is, you join proportional to degree k. You join an existing node in proportion to its degree. Okay. So, what is the if I say attachment probability of getting joined to a node of degree k is proportional to k into pk, k and number of nodes which has degree k, pk. Okay. Because I may have one high degree node, say of I have, say, n is equal to 1 and k is equal to 1000, okay, and I have n is equal to 1000 while k is equal to 2. So, what is the probability that the node will, which is more probable, that the node will get connected to a vertices which has 1000 degree, or node will get connected to a node which has 2 degree, which is more probable?
2 degree.
2 degree, because there are 1000 nodes with 2 degrees. So, although this by itself is contributing 1000, this is contributing 2000. So, it is doubly more probable that this node will connect to any of those 1000 2-degree nodes rather than getting connected to a single 1000-degree node which is present. Okay. That is why KPK. Okay. No problem. So, in order to generalize, what do we do? KPK KPK summation KPK. So, what will happen? This is equal to KPK and summation KPK is yeah, is it 2m or it will be twice into average degree. Because you are having both ways. Okay. This is simple. Think this way, k n into summation KPK. Okay. That is summation of k n k. Okay. This is what? 2e. Means 2 into number of all the edges. So, that is why it comes as 2m, okay, which is equal to m into m into n, because average is m. Okay. So, this becomes 2m. Okay. Now, what happens is you are attaching m nodes, m edges. You are not attaching one link, but you are attaching m link. So, then this again becomes k pk by 2 is a k m. What is a k m? Probability of getting attached to any of the m links. Okay. KPK by 2. Clear? No problem? Okay. So, now we try to write the rate equations. So, rate equation means what? N plus 1. So, I have this network and I have added a new node. So, initially there were n nodes, now n plus 1 node. This network now has n plus 1 node. Okay. I hope this concept is clear, that initially the network had n nodes, I am adding a new node. So, n plus 1 nodes are added. So, now I want to see how many n plus 1, how many degree k nodes are in this n plus 1 noded network. Okay. So, how many are there, and what is this, that how many were there when the network had size n. Okay. So, this is size n plus 1. So, I want to see the difference, and how can I see the difference? How many k degree nodes have become k plus 1, that should be subtracted, means that has left the k degree k family, and how many k minus 1 degree node has become k, that has joined the k family. Okay. So, then this becomes, so how many k minus 1 degree nodes have joined the k family? Simply this one we know k pk by 2. So, that will be half k minus 1 pk minus 1 comma n. Okay. Because I know what a, k, m is equal to k p k by 2. So, that is why a k minus 1 comma m is equal to k minus 1 p k by 2. Okay. I hope this part is clear. And what will be subtracted? Half k am I clear that what will be subtracted? Half k p k comma n. I hope this expression is clear to you. Okay. So, this is for m greater, so for k greater than m. So, what happens if m, let us write n plus 1 how many m degree nodes will join the network? How many m degree nodes will arrive in the network after addition of this? How many m degree nodes will come now? New m degree nodes, how many?
n into pk minus pm minus
no. Think. Huh?
So n plus 1 into p.
No, it's not complicated. It's nothing to do with mathematics. Just see this and tell me. How many m degree nodes?
One.
Just one, because no, everybody has m degrees. Everybody existing here has at least degree m, because everybody has joined with degree m. So, nobody is less than m. Okay. So, there is no probability that a m minus 1 degree node will become m. Only who will become m? The one who is joining. The one who is joining, his degree is m. So, that is the only new person who is coming. Okay. And how much is subtracted then? Half m p m comma n. Am I clear? Okay. So, these are the two basic equations which you get. Okay. Now, take equation 1, I write this 1 and this 2. Okay. We simplify equation 1. Okay. We simplify equation. So, how to simplify equation 1? So, the assumption is at asymptote p k comma n plus 1 will be equal to p k comma n equal to p k. Okay. This is the assumption. So, what does the right side become? N plus 1 p k minus n p k, which is equal to p k, and left side half k minus 1 p k minus 1 minus half k p k. Okay. So, this is what you get. Okay. Okay. So, now you can go on doing a little more maths. So, p k 1 plus half k equal to half k minus 1 p k minus 1. Okay. So, this becomes p k equal to half half goes k minus 1 and k plus 2 p k. Okay, I think this is pretty clear. Agreed. Okay, so now do this recursively. Pk is equal to okay. So, and what is Pm? Okay, let us see, simplify equation 2. Pm okay, will be equal to Pm equal to 1 minus 1 by 2 Mpm. So, Pm is equal to 1 minus m by 2 is equal to 1. So, Pm is equal to 2 minus m. Am I right? I think I am wrong. Okay. It's okay. So, now take this. So, what will it be? P m plus 1 will be equal to m by m plus 3. Huh? I hope I am correct. Huh? From this, see this. P m plus 1 is m minus 1 plus 1 m plus 1. Am I correct? So, then P k is equal to basically k minus 1 to m and k plus 2 into m plus 3, and what is P m? 2 m plus 2.
Pm plus 1 is getting from
Huh?
Pm plus 1.
I am just getting from here, instead of k I am putting m plus 1. Okay. Check whether I am correct or not. Okay. So, what stays above and what stays below? So, above what stays? M 2m stays, m plus 1 stays. Above only m and m plus 1 stays, everything else goes. See. So, 2 into m plus 1 stays, if I am not wrong. And below what stays? K plus 2, k plus 1 and k. Okay. I think now it becomes very simple. So, what happens? P k is equal to, if I think k plus 1 is equal to k plus 2 equal to k, then what we can write? P k is equal to, and the above one is a c. Let us think 2 m is a constant. So, the entire thing top is a constant. So, c into k to the power minus 3. Okay. And what do we get? That means we get a power law. Okay. So, this is the single most important result in complex networks. Okay. So, this is the most important result which solved the age old problem that why things are power law. Okay. So, we knew that rich gets richer, we knew this concept from olden times, okay. And we have people have seen, means more popular was Gibbs distribution. If you know this term, I think, yeah, I think Gibbs, PF. Gibbs distribution, you have heard this term?
Yeah.
So, it is more applicable to language. Okay, Gibbs. So, the most common word is doubly used than the second most common word. Okay, so that essentially follows a power law type of thing. Okay, it's not double used, but it has it's a factor. Okay, which is the most common word, written word? I think D, huh? Okay, so D is most, or if you see that most common alphabet is E, I think. So, E is almost doubly used than the second most alphabet. I don't know, I think it's A. Okay. So, it goes on like that. So, Gibbs distribution or this type of distribution was known long time, rich gets richer was known long time, but the question which came again, that why was there any relationship first of all between these two? That was what was established by Barabasi. Okay. It was established by Price, but most probably Price didn't understand that what he has discovered. So, he couldn't really publicize it or couldn't really bring out its importance. Okay. So, but the question which remains is, what are the questions which remain is that although this is a simplified model, we are getting the exponent as -3. Okay. Although this is a very simplified model, but we are getting the exponent as -3. So, but all power laws need not be -3. Okay. So, many power laws, it is seen that it varies between 2 and 3. Okay. It is seen that many networks, in many networks, it varies between 2 and 3. Okay. So, now what's the need? What's the need? The need is to suitably modify this model so that you can accommodate this exponent or you can explain this exponent. Okay. So, where exactly will the modification be? Can you tell me? What is the model parameter which has been taken? Huh?
Considering that every node will get only one.
Okay, there is one model parameter, that M-links. Okay, M-links. There is another model parameter or model assumption. I do not tell assumption parameter. Assumption is that every node will get 1. If that's a very good observation, that every node, actually it is assumed that only k minus 1 degree node become k, but you are adding M links. So, it can happen that k minus m degree node can become m. Okay, very good. That is one assumption. Anything else? See, here there is a basic assumption. You see this? That you are attaching, you have preferential attachment. So, preferential attachment means what? That you are attaching to a node which has higher degree. What is the other diametric opposite type of attachment which you can have? Random attachment. So, if I have random attachment, okay, that is k, that will be then AK will be proportional to just PK. So, there is no K, AK is proportional to PK, or AK will be equal to a K0 PK, where K0 is a constant. Okay.
So it will be 1 by total of.
Yeah, PK by summation K. That is 1.
Independent of PK, why? Because it should be 1 by total number of nodes if it is purely random.
That's why it is completely dependent upon PK only. What is PK? If I have, so see, P0 is say 0.7, P1 is 0.2, P2 is 0.1. Okay, then it is stored completely. I am attaching completely randomly. So what the degree node which is higher will get more probability of getting attached. Means I have simple. I have 7 1 degree node, 2 2 degree node, and 1 7 0 degree node. I should avoid 0 perhaps. P1 is equal to 0.7. So 7 1 degree node, P2 is equal to 0.2. So 2 2 degree nodes, and P3 equal to 0.1. So 1 1 degree node, 1 3 degree node. Okay. So a random attachment means what? I can get attached to any of these 10 equiprobably. So what is the probability that I will get attached to a 1 degree node? 0.7. So all 0.1 into 7. Okay. So that's why this thing comes. Okay. I think I am clear. So now what should we do? What can we do? We can basically combine both. That we can say that mostly it is random, mostly it is preferential, but always there is some sort of randomness in the system. That's why you see a Shah Rukh Khan appearing. Okay, it's not only stars, sons or daughters. Okay, you see somebody from outside also appearing. Okay? So it's preferential to the large extent, but also some randomness is there. Okay. So then what does it become? You can write AK is proportional to K plus K0, where K0 can vary from say minus m to infinity, because the lowest value of K is m. Okay. The lowest value of K can be m. And if K0 becomes infinite, then what does that mean? It becomes purely random. Okay. Okay. So then I can write again AK is equal to K plus K0 Pk into summation of K plus K0 Pk, which is equal to K plus K0 Pk. Kpk is 2m plus K0 summation Pk is K0. Okay, agreed? Huh?
Into m, we are in AKM.
I have AK, sorry, and now I go for AKM, which is equal to K plus K0 Pk into m and 2m plus K0. Okay. no problem. So, again you can write this equations. I try to write it n plus 1 p k n plus 1 minus n p k is equal to k plus 1. No, now it will be k plus k 0 minus 1 p k minus 1 comma n minus k plus k 0 p k comma n m into 2m plus k 0. Am I correct? Same thing. Okay. And if I take k 0 p k or p k comma okay, and this is a vanishing function. We think that this is an infinite graph. We need not catch this, but I am just doing this for some simplification. We need not do that, but just I am thinking that this is a vanishing function and we ignore this. It will be a vanishing function. You can think that this is an infinite graph. So, each individual case are an infinite and continuous graph. Okay. So, this can tends to 0. So, then you can write this as p k is equal, just warning, we can also not do that, even then things work, but I am just, maybe that will be given in assignment. Okay. So, okay, and Pm becomes 1, the one with joints, and it will okay. These are the two equations which you get. I simply skipped some steps, but I hope you understood that this just goes, that is why it is k minus 1 p k minus 1 and k p k. I can now take this off also for the time. Okay. At this stage. Okay. So, take
That
again.
will be k minus 1 pk minus 1.
Yes, sure. This will be k minus 1. Sorry. Okay. This will be k minus 1. Okay. So, again let me write this pk, it is 1 here minus a plus k into m 2m plus k 0 is equal to k minus 1 p k minus 1. Okay. Again I show this, I take this part here and write the equation. So, then p k is equal to actually 2m plus k 0 into k minus 1 p k minus 1 I am sorry, here also this thing is there. Sorry, here also this thing. So, this part does not come. Okay. M stays here just, and Okay. So, I just write it in a little. And I just take m down. So, k plus 2 plus k 0. Okay. I think this is clear. Am I clear? Just this m we have divided. Okay. So, then what happens? You can go on doing this and you will get k minus 1 till m and k plus 2 plus k 0 by m. Okay. And what is P m? Okay. P m, let us, I think we have space here. So, I write P m. P m is equal to 2 m plus k 0 m square plus 2 m plus k 0. Okay. See, this was what P m was. So, just I write it. So, I have taken this. So, what happens is P m 1 plus m square 2 m plus k 0 and this is equal to 1. So, now I hope I am clear. So, if I divide it by m both side, then the top becomes 2 plus k 0 by m and bottom becomes m plus 2 plus k 0 by m. So, this is a continuity you can see. Okay. So, the So, again just if you remember price model, what was it that k okay, that is basically summation of k plus 3 k minus 1 and 3 plus k 0 by m. See the bottom and I am just writing this. Okay. Okay. And then what you can write this? You can write this as a beta function of k 3 plus k 0 by m and beta function of m 2 plus k 0 by m. I think I have explained extensively how to do this beta function in price model. So, just for your recapitulation was where gamma A is, tell me what is gamma A? A gamma. Okay. So, it comes, let us I think I have explained it and I need not do it here again, it comes again. And what is the, so the bottom is, see this equation now, Pk, the bottom is a constant because bottom is not dependent upon m. So, it is a constant, it is dependent, it is not dependent upon k, it is only dependent, the bottom part is only dependent upon m, and where m is a constant. So, this expression is a constant. So, it just depends upon the top. And what we did, we tell that asymptotically for higher degrees of k, this will BAB becomes what? A to the power minus b, if you remember. So, this becomes Pk is proportional, then proportional to k to the power minus 3 plus k 0 by m. So, it is now not, and k 0 is varying from minus m to infinity. So, now you have, it can, if it is minus m, then this becomes 2. Okay. So, it can vary from minus 2 to infinity, means if this becomes infinity, means k to the power minus 7, 8, 10, 11, no problem. It becomes 2m, say, then this becomes k to the power minus 5, it becomes m. Okay. So, it can vary from 2 to anything. And it is seen that in real life network nothing is less than 2. Okay. No exponent is less than 2. Okay. So, I hope the generalization is also clear, and I hope you liked it. Okay. So, you have the price model, which has, means this is basically again revisiting price model. And see, if we think carefully, it is basically revisiting price model in a little better way. Okay. So, the next question which need to be asked is, I would not say limitations, but some of the properties. Properties of BA model. Okay. The first property which was looked, so which was looked is that you have a k, you have degree k, and you have a age. Okay. So what will happen? Tell me that if I have, means in this typical model, what is happening? If I come first, most probably my degree will increase. So there may be some relationship between my age means when I have come, whether I have come at t is equal to 1 or t is equal to 75, it matters, age and the degree. Okay. And then there were various rigorous works to find that whether this relationship exists or not. And there is a work by Kaprivetsky. I will do Kaprivetsky's other part, but so Kaprivetsky rendered, they are the other people who contributed a lot in this evolution other than Barabasi-Albert. Okay. So Barabasi-Albert was one group which really contributed. Kaprivetsky render was another group which contributed, and another good big name is Dorogovtsev. Okay. So these were the three people or three different groups who really contributed in developing this theory. Okay. So what Kaprivetsky found is that it is positively correlated, and you have Okay, there was some sort of relationship which he found, that as you have higher edge, your probability of getting higher degrees increases. Okay, and then the second thing which which atomic Huberman found was that degree correlation. Okay, what is degree correlation? Degree correlation we know. So the question was this simple: Barabasi-Albert model, is it doing something purely random, means purely random in terms of degree correlation, or is there some, means it is connecting, or higher degree nodes are getting connected to higher degree nodes. Okay. And for that what he did, he just changed the, means in order to analyze, he changed the model and thought that when you are coming in, you are coming with directed edges. Okay. So he brought in the concept of directed edge, means the whole analysis or whole development at undirected edges, and he brought in the concept of undirected edge, and he showed that EJK, okay, EJK follows some formula, and this is the formula. I think I don't write it because it's a complicated formula which shows, means you need not really know it, but which shows that there are some degree correlations. Okay. Okay. So the next question was that how to implement Barabasi-Albert model. So the question is implementation of BA model. Okay. What is the problem of implementation of BA model? That what am I telling? I am telling that I will get attached to a node with degree k. Okay, I will get attached to a node with degree k, or it's proportional to the degree. So how to implement that? In order to implement that, that means what I have to do? Tell me, Arpit, what should I do?
Create the studs and then.
Yeah, means I have to check all the degrees. Okay, and then take a probability distribution of those degrees and then work upon it. So at each step when I am coming, what is happening? That I have to know, I have to look at the entire network. Otherwise there is no other way out. I have to look at the entire network and then find out that which network has which degree, which node has which degree, and accordingly take the decision. First of all, this is algorithmically intensive, and also practically this doesn't happen. Okay. So for algorithm there was a suggestion, algorithmic suggestion was, can you give me the algorithmic suggestion? Algorithmic suggestion was simple, that you have, say, n1 is equal to 5, n2 is equal to 10, n3 is equal to 2, n4 is equal to 7. Okay. So what do you do? So what will happen, that this has probability of choosing 5, this is 20, okay, this is 6, and this is 28. Okay. So what I do, I make an array, I write 1 5 times. Okay, I write 2 20 times. Okay, means it need not be that I write all ones then twos. I can write, then I write 3 6 times. Okay, and then what do I do? I just randomly pick one number. Okay, I just randomly pick one number. Okay, I just randomly pick one number, and immediately I solve the KPK problem. Okay, immediately I implement the KPK concept. Okay, so anyway, so these are some of the various variants of Barbasi-Albert model. Now, some other important thing is what we have thought. We have thought that it is KPK or it is proportional to K. It could be proportional to the K to the power alpha. Why K? It can be proportional to K to the power alpha. So, what happens if it is proportional to K to the power alpha? Okay. Does then also we get power law, or there is some difference? This we will study in the next class. Thank you.